in the room, how many of you use Twitter on almost a daily basis? Great. If you see ads and if you think that they are like very much related to what you like, what your preferences are, you know one of the person behind the team. Hi, I'm Jigyasa, and I work on the ads prediction team at Twitter. And today we'll be talking about different Python programming paradigms in Python. So the year of 2018 has been long gone. It has been long dusted. And with every new year, with 2019, flows in the TIOB's programming language of the year. How many of you in the audience know what TIOB exactly is? TIOBE. So for those of you who don't know, I see it's more than like 95% of the audience. It's the importance of being earnest. It's a software quality company based in Netherlands. And what they do every year is basically see the search engine ranking points for each programming language and see what is the most popular language of the year. And I was not at all astonished to see that in the year 2018, Python won the #1 language of the year, after having captured the most search engine ranking points. Also earlier this year in 2019, 90,000 developers from all across the world took the 20-minute survey conducted by Stack Overflow, the 2019 developer survey. And the results showed that clearly Python was the fastest growing major programming language, and it has risen to the programming languages out yet again, edging out Java, C++, and all those things. Ever since I've gained consciousness in this tech sphere, it has been probably 5 to 6 years now, not long, but I've observed that the admiration of Python has been soaring high. And the sources reveal that it has been consistently in the top 10 programming languages since the year 2003. 16 years and always on the top 10, and now at top 1. As the recent article by TIOB mentioned, there's an excerpt that says, it's the most frequently taught first language in university these days. It is #1 in statistical domain, #1 in AI programming, #1 in scripting, #1 in writing system tests. Besides this, Python is also leading web development and scientific computing, just to mention a few. In summary, Python is definitely everywhere. And of course, there are so many reasons for the rapid rise and modern dominance of Python in multiple domains, comprising of readable and maintainable code, easy syntax, modular, dynamic, and portable nature, such a great community of developers out there to help you every time, the productivity in which you can program, and of course, the speed. But what wins the cake is the flexible programming. Flexible programming of Python, only few languages are something that can attain that level. It lets advanced developers coming from all different kind of backgrounds, any language they have programmed in earlier, to use the style what they feel is the best to solve a particular problem pertaining to their use case. So basically, when you work with Python, you are the snake charmer. You can actually code in any style you want. Imperative programming, functional programming, procedural programming, object-oriented programming, the major 4 programming paradigms, all are supported by Python. Thanks to the open source developers out there. Let's have a round of applause for all those developers. So before we jump onto the jigsaw puzzle of what programming paradigm should I use when while using Python, let's do a very quick revision of all those 4 paradigms. Let's start with the basic imperative programming, the king of all. You start off with imperative programming whenever you talk and whenever you wish to write a program. It's a series of commands. It basically follows as you want to do something. It follows the natural mood of your language. For example, when you want to make tea, you basically do the following steps. Take water, boil the water, put in a tea bag, and so on. So just step by step, that's how the execution is done in imperative programming. It is very simple, elegant code, and just sequential. But that's why it also ends up being bottleneck for the hardware utilization and, of course, complex data science applications. The one thing to be noted is it's for the stateful programming model, means that every step of the program, every step of your making tea, you're able to have like a product, like an end product till that particular step. So that's what is known as stateful programming, because you can go through different states. As we all know, talk is cheap, show me the code. Let's have a very simple example where you have a list of different characters, and all you want to do is concatenate them. So while you concatenate in very simple natural language, or how do you think? You basically would take an empty string, then start putting each character one by one, and that's how you do in imperative programming as well. Just here that I've made a loop, and if you just basically stretch it out, it would be a big program sequence by sequence. What I meant by stateful programming was, at each step, I'm able to retain that string, basically what actually the end product till that step I could have gotten. So that's, in very simple words, what is stateful programming model. Moving on to next, functional programming. In functional programming, basically, you think in mathematical terms. You don't tell how to solve, you basically tell the computer or the language what to solve. It's declarative and promotes stateless functions. Stateless as mean we cannot retrieve the state of the program at different steps. We'll see with the example in a few moments. The best thing about functional programming is parallel processing and recursion in very easily, and a declarative programming paradigm as well. So let's just see the same example if we could have done it in a functional programming manner. In functional programming, if you see very carefully, I've just imported Func Tools and then taken the sample characters and put them through a bunch of functions. Func Tools.reduce and then given a Lambda. Let's dive deep into it and see what exactly are these three different components. Because as you see, in imperative programming, we were doing step by step, and in functional programming, we all combine it into one single step. And point to be noted is, we'll always get the python string. You would never get pyt or pyth. So no states can be retrieved in this method. The first thing is Func Tools. Func Tools is nothing but a library that takes in a function and gives a function. It helps to write reusable code because every time you can just pass it a different function and it will apply another function on top of it. That is basically a library that is inherent to Python. Then comes up the second thing we saw there was reduce. Reduce is nothing. It just takes a big string of stuff and compresses into one single value. Let's see an example because how easy it is for us to understand. For example, you have a string, a list say 1, 2, 3, 4, 5, and you want to compress it. You want to have a single value out of it. You want to basically reduce it. You'll have a function, a reduce function, and pass it the sum method. And what would it do is 1 plus 2, then plus 3, then plus 4, and then plus 5. It would compress all the singles list into one single value. That's what reduce basically does in layman's term. The third thing that we noticed there was Lambda. Lambda is nothing but small anonymous function, like nameless functions. They are functions, but they don't have a name. But there are few properties of Lambda functions. That is, they can take any number of arguments, but the catch point is they always have to they always have to return one single value. And the power of Lambda is best shown when you know that that particular function that you have defined might not be used anywhere else. It's kind of like an inline function, and they're best used when you use them inside of another function. So let's see another example of Lambda, which is the same example. The sum function you passed on was as a Lambda function. So you had Lambda x comma y, which returned x plus y, and that method was applied to list and passed into reduce. This can be a little bit complicated, and you need time to understand all of these things, but trust me, functional programming is an art, and once you've mastered that art, it can make so many things easier. So going back to that same very example, we took a sample string, and then we had Func Tools basically calling a function. We had reduce, and in reduce, we basically had two arguments. The function to be applied on that particular array or list, and then the list itself. This can be, again, a little complicated for those of you who don't come from functional programming background, but it is the easiest and the single-step method of converting a big string into a single value. Okay, it might be a little overwhelming, so just move on to the next programming paradigm, which is the procedural programming paradigm. So procedural programming paradigm is just like imperative programming. It's a subtype of imperative programming, actually. But instead of having step-by-step commands, we have step-by-step function calls, and those functions might reside anywhere in your project directory. It is a very old form of development, and just like imperative programming, it's a stateful programming model, and it favors sequencing, iteration, selection, etc., thus, again, being a resource utilization bottleneck. Let's just see the example again, follow the routine. This time, this is my main call, which is I made a function stringify, which could have been located anywhere else in my project directory. And what I'm doing is I'm basically making the call in a sequential manner, and that's how procedural programming works. Of course, I can print out the values in the function itself, and it will give me the different stages of the function. But the thing to be noted here is we are doing functional calls. We're modularizing the code. And basically, a program is nothing but a combination of modules, a combination of calls that you have done. And they can have no relation with each other and can be placed anywhere. So this was all about procedural. And let's just finish off with the revision that is object-oriented programming. All of you know, like most of the people who come from C++ and Java background must be knowing what object-oriented programming is. It basically encourages code reuse, and everything's in form of objects, each having their own attributes and methods to change. It's complex because it can lead to very much tricky implementation. And a thing to be noted is Python does not support fully object-oriented programming because people who come from C++, Java background know there's always a private keyword, which is missing in Python. So we cannot actually implement absolute data hiding. All we can do is prevent it by putting double underscores in front of the methods and the attributes you want to basically mention as private. But of course, you can always access them. And if you see the same very program, if written in object-oriented programming, can be so much more bloated because first of all, you'll have to define what a string ops class basically, then have a method, then have attributes and so on. So first you'll initialize the class, then you call the method on it, and then you'll basically print out the stuff. So that brings us to the point that are we actually comparing different programming paradigms? Because in this particular example, we saw that how functional programming could have given us the same thing in one single line, but imperative programming was so much easier to write, and object-oriented programming basically blew us off because it bloated the code so much. So what I'm planning to say is software is knowledge representation, and what you want is totally dependent on how can your problem be best represented. So let's just see in very simple terms, how can your problem be best represented? If you think it's a series of simple manipulations, you just have one value and you keep on iterating over it and just tweaking it up, imperative might be the way for you. If you think your program is more of a mathematical stuff, you have lots of mathematic functions going on, you have filters, you have mappings, you have reductions, etc., functional might be the way. But if you think your program is more of like you have different entities, each having their own attributes and values and specific set of methods that only those can be used to change them, then object-oriented might be the way. But then, of course, real-life use cases cannot be that simple. You have to also take care of scaling, dynamic needs, etc., etc. So now that we have done a quick revision, let's go on to the buzzwords. There comes the fun part of today's actual talk. So when I talk about buzzwords in today's tech world, what's the first buzzword that comes into your mind? Blockchain, AI. So yes, of course, machine learning, AI, I'm an ML engineer. So that's the first buzzword that also comes into my mind. You can actually apply artificially intelligent machine learning in front of any of your product, startup idea, and it, of course, will gain so much more funding. So let's talk about machine learning and how and what programming paradigm must be the best suited for machine learning. So as you know, it might not be that easy, and you always need a mix and match. So machine learning can be a perfect blend of functional programming and imperative programming with, of course, the dash of immutability we have. Let's see how. When you basically do machine learning, the first and the foremost step is pre-processing the data and feature extraction. And that's the best done in a functional way. How? Because most of the time when you are doing data pre-processing, you're basically doing lots of mappings. You're filtering out the stuff you don't need. You're doing lots of reductions. And when you're doing feature extraction, for example, I have a model that basically takes eye colors of everyone. I might not use the exact string like blue eyes, black eyes, brown eyes, hazel eyes, etc. I might categorize them. I might make like an enum of them and map like brown to 1, black to 2, and so on. That kind of mappings can be easily done in parallel way because they do not depend on each other. And hence, functional programming, a mathematical filtering reduction might be the way to go. But when you do training, you have to go in a sequential manner as you have to go through each data point and then basically keep on updating the loss. And you need that loss thing, the thing that you're optimizing at each step. That means you need the stateful type. As we discussed previously, you do need state of each basically training step, and how old school imperative would be the best to go. It is quicker than functional, and of course it avoids creating copies of each thing because you're basically taking that loss function and updating it each time. So this is how you have to mix and match different programming paradigms to achieve what is the best for you. Now comes the next buzzword. Any guesses again? No, this time we'll be talking about deep learning, because deep learning is nothing just a more fancier term for machine learning. It is a subset basically where you have a specific set of model, which is the deep neural network. And it looks something like this, where each of the circle is basically a neuron. And how you calculate neuron and how basically you calculate the values of each of the weights of the neurons and how they contribute to your model is something like this. Now let's not go into more mathematical formula, but just take in mind that each neuron weight basically depends on previous neuron's weight or some previous input that it must have. And as long as it has that, it does not care where are the other neurons in their stage of processing. Hence, you can always use functional programming in this way, because this way would help you do concurrent and parallel calculations, because weights of the neurons are immutable and stateless, and updates can be actually applied anywhere and any time of as long as inputs are computed. So deep learning models are compositional. There's a lot of math that goes behind it. So just like a layman's term, math is equals to functional and so on. And of course, the entire process of DL, deep learning, is basically to optimize a set of functions that you have. There's another ML paradigm that has resurfaced, which is a combination of functional programming for writing statistical models and information theory to basically prevent overfitting. The point I'm putting forward is you don't always have to just take one programming paradigm and just stick to it. You can always have different components in different programming paradigms and then just combine it. There's a paper on it, inductive logic programming, if anyone is interested in it, and not going deep into it, just to make sure that the audience is on the same level here. Now coming to the last programming, one of the buzzwords we have is data manipulation, how you basically have a bunch of data and you want to manipulate it. Again, there are a couple of options that you can follow. The first is functional programming, obviously. We know why, because you have pattern matching and etc., etc. But then again, the downside is it is not easy to write functional programming. A lot of thought goes into it on how you can basically have such a big logic you have and how you can combine it using Lambda calculus into like a single line or a 2-line code. But of course, it's an art. You have to master it and it takes practice. The second is object-oriented programming, because you can basically create object types for each of your like in Scala, you have type pipes, etc. And then you can basically write out your data manipulation or your jobs. But again, the downside is we saw that how things go back and forth in object-oriented programming. You'll have to always go back to the object definition, then go back to the attribute, then to the method. And it's not written in a very readable way. It requires, it's a tricky implementation, and it's very complex. But of course, it totally depends on you. As both the paradigms have automatic garbage collection system sort of, and they can access and manipulate databases smoothly and equivalently. And it, of course, heavily depends on the programmer's choice and knowledge, etc. So now that we've talked about different programming paradigms, which were imperative, functional, object-oriented, and procedural, we also talked about buzzwords in today's world and how different components apply different kinds of programming paradigms. What's the best takeaway from this talk? I'm trying to keep it very short. The best takeaway from this talk is you always have to mix and match. You cannot stick to just one programming paradigm, but try not to make it too complex. And the second is, of course, because it's Python, it's an open source community, always jot down your solution, you think what is your best, and share it with the community. You'll get feedback, you'll get how you can improve over it, and you might find that single style does not affect all of it, and what if today's problem solved can become tomorrow's time-saving template for everyone. Thank you so much, and I hope you really enjoyed, and let me know if you have any questions. Thank you so much.
Before we go to the question session, I want just to quickly introduce Jigyasa. Guru is one of the Red Hat women in open source academic award winning in 2017. She's a Google Summer of Code alumna, and currently she's a mentor and administrator, and presently a machine learning engineer at Twitter. Jigyasa Guru is an open source enthusiasts and aspires to inspire a powerful bunch of girls and boys alike and help bridge the gender gap in technology. So do you guys have any questions for our presenter?
I was wondering if you could give an example of where you've mixed and matched the paradigms to better success than just using one alone.
So just as I talked about the machine learning example, so whenever we do just do like a simple machine learning model, I always try to do. So when I was a grad student, I did my specialization in artificial intelligence. And the first day I started writing, the first of the basically questions we had in homework was to do a bunch of data pre-processing, and I was the one who was trying to do it sequentially. And my Jupyter notebook ended up being 100 to 100 lines, and that's when I saw a friend's Jupyter notebook and realized how he had basically done all of it in not less than 20 lines. I realized how functional programming can be applied for data pre-processing stuff. It took me 2 years to basically write a decent functional programming way, but whenever we used to do kind of training of the model, we always have a loss value or something, and we try to minimize it, and you have to iteratively go over all the data points you have. So that's how imperative programming comes in. So it's a very brief overview.
Do you have any debugging techniques for functional programming?
So that's the tricky part. So what I try to do is, so as we talked about, say, Func Tools.reduce and Lambda and all that stuff. So basically what I do is I try to do it first in an imperative sort of way and then keep on clubbing the values. And yeah, it just takes time. That's how I learned, yeah. I used to keep on clubbing and then make a single line of values.
We have time for 1 or 2 more questions. Thank our presenter.
Yeah, thank you so much.